So on the next page, on page 124, we are actually looking at this graph. And so the graph itself is just this straight line. These little things that they added in, the little steps, are not a part of the original graph. Those are just there to help you see what's going on. So we're looking at this graph of this straight line. And it says vertical change can be represented as a change in y, and horizontal change can be represented by a change in x. So the vertical change, remember, is the change going up and down. That's what vertical means. I would draw myself some arrows to help remind myself. And the horizontal change is going side to side. So first he wants to know, what is the vertical change? So we're talking about going up and down, straight up and down, not diagonally. What's the vertical change between A and B? So if I want to start at point A and go to point B, how far straight up do I need to go? 3. 1, 2, 3 points. 3 units. So that would be 3 units straight up. Now we want to know how far straight up the vertical change between points A and C. So you might want to kind of connect these to make it easier on yourself to see exactly where you're going. So how far straight up do I need to go to be able to get from A to C?
6.
That would be 6. And then the last one, from C to D. 3. Then we need to talk about the horizontal change. So the horizontal change between points A and B,
4.
so we're just going straight across, that would be what?
4.
4. The horizontal change between A and C,
8.
so you need to go all the way across, that would be 8 units. And then the horizontal change between C and D,
4.
4. Does anybody need clarification on where those numbers came from? We're good on that part? So we are just literally counting how many spaces to get over from one thing to the other, either vertically up and down or horizontally side to side. So the ratio, remember a ratio is when we compare two numbers, of a vertical change to the horizontal change determines the slope of the line. This is a very, very important word, slope. You're going to talk about slope a lot. So a slope of a line tells you kind of how steep it is. So if you think of a ramp or a hill, it has different slopes and it's different amounts of steepness. It can be really flat. It could go like straight up and down. It could be tilted. Those all would be the different slopes. So to find the slope, it's comparing the vertical change to the horizontal change. Or we can say it's comparing the change in y to the change in x. Because change in y is vertical. Y is up and down. X is horizontal. It's side to side. And these little triangles, these just mean change. So this is a shortcut way of saying the change in y and the change in x. And we're going to add one more thing that this is. We also call this the rise over the run. So when we talk about slope, we are measuring the rise over the run. So if we want to find the slope between points A and B, we want to find the rise over the run. So how far does it rise to get from A to B? It rose 3. We figured that out already. We figured out the vertical change. It rose up 3. And how far does it run to get from A to B? 4. So the slope would be 3 over 4. Now A to C. So how far does it rise up to get from A to C? 6. And how far does it run over?
8.
8. Can we reduce that?
Yeah. Yes.
To what?
3/4.
3/4. Point C to D, what is the rise? 3. And what is the run? 4. So what do you notice about the slope of the line from all three?
They're all equal.
They're all the same. They're all equal. Yes. I'm sorry, what? If it's all on the same line, yes, the slope will equal each other. So if you picked any points to compare, their slope would all reduce down to 3/4 on this line. So that kind of answers number 6. What is your answer to 5? Indicate about the points on a line. That any 2 points on a line will have the same slope. All right, so it says slope is sometimes referred to as the rise over the run, which I just told you about. We're going to skip down. We're going to skip down to number 9. So we're actually going to find the slope of this line. You can pick any 2 points you want because they will always reduce down to the same slope. The only thing you want to make sure is that you're picking what we call pretty points. You want points that are easy. They're like crossing exactly in a spot. They're not in between lines. So I'm going to pick this one right here as my first point. And then I'm also going to pick this point over here. So to find the slope, I need to find the rise over the run. So what is the rise?
3.
It goes up 3. And what is the run? 7. So the slope is 3/7. Any questions? All right. So that's easy to find it from a line, from a graph. But what if we don't have a graph? What if it's too big to graph? We need to think of other ways how we can find it without using a graph. So it says, although the slope of a line can be calculated by looking at a graph and counting the vertical and horizontal change, it can also be calculated numerically. So recall that the slope is the line is the ratio of the change in y to the change in x. So first, let's go back. What were those 2 points that we just picked on that previous graph? So it should be 0, -3, and then 7, 0. Make sure that you're doing your ordered pairs correctly. You started 0, 0. I went left to right 0, and then I went down 3, so that would be -3. And then for the second point, I went to the right 7 and up or down 0. So right 7, and then up or down I went 0. So those are my 2 points. I'm going to go ahead and plug them into this table on page 126. So the first point we said was 0, -3. And the second point was 7, 0. What coordinates relate to the vertical change, to the up and down change? The y coordinates. Which are what in this case? What are the 2 y coordinates? -3 and 0. And which coordinates relate to the horizontal change? The x coordinates, which in this case were 0 and 7. So first it wants us to determine the vertical change. So I want to know how far up and down did it go. So we just said vertical change was the y coordinates. So what is the distance between 0 and negative 3? 3. And then the horizontal change, so the side to side change, it from 0 to 7, the distance would be 7. So then if we're going to find the slope of this line in part F, remember that we do the vertical change, which is the change in y's, over the horizontal change, or the change in x's. So the vertical change we just said was 3, and the horizontal change was 7. So that is the mathematical way to compute this without looking at the graph. So if other students in the class had picked different points, would they have found different values for slope? No, why not? Right. If any points on the same line will have the same slope. All right, so here's those things we started talking about when we were solving literal equations. It says it's customary to label the coordinates of the first point x1, y1, and the coordinates of the second point x2, y2. So all that's saying is the first x, the first y, the second x, the second y. So I'm going to give you an example of the one we just did. If we had 0, negative 3, and we had 7, 0, then we could say 0, negative 3 was x1 and y1. And 7, 0 would be x2 and y2. This is saying they want us to write an expression to calculate the vertical change, or the change in y. So if we want to calculate the change in y, we can subtract y2 minus y1. That would tell us the difference, the change from y to y. If I wanted to calculate the horizontal change, or the change in x, I would do the same thing with the x's. I would do x2 minus x1. Then it wants us to write an expression to calculate the slope of the line through the 2 points. I'm just going to go ahead and give you the whole formula. So the formula is m, which stands for slope, which no one really knows why m stands for slope, but it does. M stand no, because I promise you it's gonna all tie in a little while, and you have to have m. So m stands for slope, and that is y2 minus y1 over x2 minus x1, which I also wrote on the board. This formula is very important for you to memorize and know how to use. Once you do it a few times, you're going to just remember how to do it, and it's not going to be that hard. But while you're doing it the first few times, you need to make sure that you are using the formula. Do not tell me, well, I wasn't sure which one to put first. The formula tells you which one to put first. y2 minus y1 over x2 minus x1. So let's go ahead and look at the check your understanding number 12. So again, I'm going to do this one with you. M equals y2 minus y1 over x2 minus x1. Get used to writing that. And then it's asking you to find the slope between these 2 points. So we are going to label those 2 points. The first point is x1, y1. The second point is x2, y2. So the first x, the first y, the second x, the second y. So we're going to plug it in. What do I plug in for y2? Negative 6. Minus, what do I plug in for y1? 9. Over, what do I plug in for x2? Negative 8. Minus, what do I plug in for x1? 4. So at the top, negative 6 minus 9, what is that?
15.
Negative 15. And what is negative 8 minus 4? Negative 12. Now, something we did not talk about yet, because this is a ratio, can it be a decimal?
Yes.
No, a ratio is comparing two things. It cannot be turned into a decimal. Can it be turned into a mixed number? No, it is a ratio that is comparing two things. It cannot be a decimal. It cannot be a mixed number. So it's either going to be a fraction or it's a whole number with the understood 1 as the denominator of the fraction. So simplify negative 15 over negative 12 just by reducing it. What are we reducing by? 3. So that would be 5 over 4. And both of them were negative, so that means that the answer is going to be positive. Because a negative divided by a negative is a positive. So this would be 5/4 is the slope for number 12. So m equals 5 over 4. Now use this formula, do exactly the same thing for number 13 on your own. So for number 13, first you label them. You should have x1, y1, x2, y2. And then you go ahead and plug that into the formula. So m equals y2 minus y1 over x2 minus x1. What is my y2? Negative 10. What is y1? So negative 10 minus negative 3 over, what is x2? 9. Minus, what is x1? Negative 5. So negative 10 minus negative 3, you keep change. So that is going to be negative 7. Over, what is 9 minus negative 5? We keep change and get 14. So we have negative 7 over 14, which reduces to negative 1/2. So that's the answer to number 13. Number 14, how can we find the slope of a line from a graph?
By using the slope line.
Just count the rise and the run. All you need to do is count the rise and the run. Number 15.
Count?
Yes. How do you find the slope when you are given 2 points and no graph? The slope formula. So m equals y2 minus y1 over x2 minus x1. All right. Number 16. We're going to skip number 16. Number 17. So Connor and April have both tried to find the slope of these 2 points, but they both worked it 2 different ways. Which one is correct?
It's the second one. No, wait. They're both incorrect.
The second one.
The second one is right or wrong?
Right.
How do we figure that?
No,
let me look
both
at it.
are
Let me
wrong.
look at it.
Because
No, they're both
she
wrong.
she put 3 minus negative 2 and it's negative 3.
Okay, so you could just rearrange the points and make this x1, y1, x2, y2. That's fine. That's not the issue. There's a different problem.
They're both wrong.
No,
No, Megan, they aren't.
No, the second one is.
So if you switch the points, which
Oh,
Destiny?
It's the first
Yeah, it's the first one.
Destiny, why is the first one?
because at the bottom for the X one, it says that to subtract 3, it should be subtract negative.
Nope.
No.
Wait, it's the first one.
What are the X's here?
The bottom one. Wait.
-2 and 3, and where should they be?
At the bottom.
Which one has -2 and 3 at the bottom? The first one.
So it's okay. It's
So-
okay if we switch X1 and
Yes. Connor is correct because April had it upside down.
stupid April.
Wait, Connor is correct or incorrect?
Correct. April just.
What's the one?
Okay, it does not matter. Listen again to what I just said. It does not matter. You can make this second set of parentheses the X1 and Y1. Because they could have just put that ordered pair in front. It does not matter. That has nothing to do with it. You could put those in whichever order you wanted to. It's just whatever set you choose to be the second set needs to stay the second set. You can't have an X1 and a Y2 in the same parentheses stored in.
So does that seem like 3 was minus?
18, they are giving you a table with no graph and they are asking you to find the slope. You can choose any 2 points you want off of this table. I'm going to choose the first 2 to make it easy on myself. So I'm going to rewrite this. I have 5, 5, and I have 7, 3. So I'll label them X1, Y1, X2, Y2.
Yes.
And then I plug it into my formula. So M equals Y2 minus Y1 over X2 minus X1. So Y2 was 3 minus what's Y1?
1, 5,
5 over what's X2? 7 minus X1?
5.
5. So what is 3 minus 5?
-2.
And 7 minus 5?
2.
So -2 over 2 simplifies to -1. So the slope would be -1. And then the last one we look at this graph and we have to determine the slope. So we find 2 pretty points. So we could do this point right here and this point right here. So remember we're looking for the rise over the run. How far up does it rise? 2. And how far over does it run? 1. Which reduces to
2.
2. So the slope equals 2.